Wonderful to be here with you. Let me give you a scientific update of the challenges we're facing with planet Earth. And just to summarize, in just 2 words, we are in danger. We can today unequivocally, with all the scientific evidence we have, for the first time in human history on planet Earth, conclude that we are at risk of destabilizing the beautiful blue marble, our home, planet Earth. This has never been the case before. I mean, we've been studying a lot of environmental challenges. Sustainable development has been growing over the last 30, 40 years, but now we have the evidence we are at risk of destabilizing the very basis of life support for human development. We are at risk of kicking the planet out of its healthy state, that it's at risk of rolling away, drifting away from the basic life support that we depend on. So let me tell you this story, but also give you the final conclusion on the window of hope that we still have for a transformation, which I call for a safe landing, for a prosperous and equitable humanity on Earth. The first insight is the empirical evidence from all the observations that we have increased our pressures on planet Earth in an exponential way. You've seen the hockey sticks. It's scientifically now defined as the Anthropocene. Greek anthros for humans. We, anthros, constitute today the largest pressure on Earth, exceeding even the geological forces like solar voltaics or like solar radiative forcing, volcanic eruptions or earthquakes. We are now in the driving seat of changing the conditions on Earth. This started in the 1950s. Up until that point, we had linear change, and then we go off in this exponential rise. We can now conclude, in very simple terms, that up until roughly the 1980s, we were still a relatively small world on a big planet. You could argue that unsustainable consumption and production practices, which were still wrong already at that time, did not have invoices being sent back from the planet because there was ample ocean, ample trees, ample biodiversity, ample atmosphere, ample ice, ample atmospheric ozone stratospheric layer that protected us against pressures. From 1950s onwards, that is now finished. We've now come to a point where we're starting to hit the ceiling of what we today can call hardwired processes that regulate the functioning of the planet. Welcome to the Anthropocene. We are now a big world on a small planet, no longer this small world on this infinite planet. Insight number 2 is that the planet is a self-regulating geophysical system with all the spheres, the biosphere, the hydrosphere, the cryosphere, all the ice sheets, but also the hydrosphere, the bloodstream of the very planet, the freshwater cycle, which is behind all life, all biomass, all carbon sequestration, regulating even the stability of the climate system. Now, these spheres are so interconnected that we now understand today that the planet is a self-regulating system. And if you stress this system, when she is in a healthy state, she will buffer and dampen and do everything she biogeochemically can to remain in a stable state. We call this resilience. Resilience is the ability to take stress without falling over. And we now study what we call tipping points, being the biogeophysical systems that have multiple stable states, but push them too hard and the systems will topple over, and a healthy rainforest can become a desertified, arid steppe, or an ice sheet, a stable cooling system that reflects 90% of incoming heat back into space. It's a cooling mirror to have a beautiful Antarctic ice sheet. When that melts too far, it darkens, absorbs more heat, and self-amplifies and becomes a self-warming system. That's a tipping point. But insight number 3, dear friends, is the most deep one, and the one that really, really anchors why we have to become stewards of the entire planet. And that is from paleoclimatic data, from our ice core data, which now dates back 1 million years, but we actually have modeling data all the way back through the entire Quaternary, 3 million years of the journey of planet Earth. And what it shows is just astonishing. It's just beautiful and remarkable. And it goes as follows. the last 10,000 years, since we left the last ice age, is geologically defined as the Holocene. The Holocene is just a remarkable, healthy state of the planet. Can you imagine? The average temperature on Earth is 14 degrees Celsius plus minus 0.5 degrees Celsius. The planet is wobbling within this extremely narrow corridor of life. Everything we cherish, everything we love, everything we depend on, all the ecosystems, the forest, the fish in the ocean, the rainy seasons, food, everything we know, spring, summer, autumn, winter, established itself within this narrow corridor of life. It's so important that you know the story. We've been modern humans on planet Earth for roughly 250,000 years. We've lived through 2 ice ages and 2 warm interglacials. We were hunters and gatherers. We lived in caves. We had a rough time because environmental conditions were dashing up and down. In just decades, we could have plus minus 10 degrees Celsius, back and forth. We leave the last ice age some 18,000 years ago. We enter the Holocene. We barely enter it. And what do? Well, the conditions become so beautiful and so stable and so predictable on planet Earth. So we go through the most important revolution, the deepest innovation of them all through the history of modern humanity on planet Earth, the Neolithic. We domesticate animals and plants. We become farmers. We settle down in villages, and off we go in the innovation pathway that has taken us to the globalized world of today. And now we are soon 9 billion co-citizens on planet Earth. And the only ethical conclusion you can draw of this is the following. The Holocene is the only state of the planet we know for certain, dear friends, the planet on the screen here, that can support the world as we know it. We've lived outside of the Holocene as a few million people in caves as hunters and gatherers, but there's no proof anywhere that we can ethically and responsibly cater for 9 billion people in the life that we define as dignified life outside of the Holocene. So that is the scientific picture today. We're in the Anthropocene, at risk of kicking the planet out of its stability domain. Tipping points are real, self-amplifying risk, and the Holocene is the reference point for the desired planet. Put all this together and you have the mix. We have to become stewards of the entire planet. But you may now ask, of course, wonder, but why did the planet stay within this extremely stable corridor of life? Was it so that the sun was so gentle to us that the wobbling of the Earth axis has somehow halted down? The answer is no. It isn't only the sun's gentle rays that kept the planet within this narrow corridor of life. It's also, we understand today, the health of the planet. This is why we must now take the planet to the doctor. We must now bring the planet into a full health check, and that is what we scientifically are today able to do. And I will now be showing you a few elements of that health check. And the number one data you have on the screen here. I would argue this is probably the most important graph we have today on health point number 1 with regards to the ability of the planet to cope with climate stress. What is it that you have here? Well, on the x-axis you have from 1850 until today, the entire era of our industrial revolution. This is basically the era of coal, oil, and gas, fossil fuel emissions. Above the zero line, you have the hockey stick of fossil fuel burning in red and degradation of ecosystems and deforestation in yellow. That's the greenhouse gases we've emitted into the atmosphere. So, is it the area under this curve? Is it the entire volume you see above the zero line that has caused the climate crisis so far, the 1.2 degrees Celsius of warming we see today? By the way, the warmest temperature on Earth over the past 100,000 years? The answer is no. Because look at below the zero line. In green, dark green, you have the carbon uptake in the ocean. In light green, you have the carbon uptake on intact nature on land. All the living remaining ecosystems, roughly 50% of land area on planet Earth. It's only the blue sliver you see there that remains in the atmosphere, causing the global energy imbalance, which has led to the climate crisis, which today leads to so many climate extremes in terms of droughts, floods, heat waves, fires, that are actually costing the global economy in terms of invoices back to societies in the order of $200 billion just in the year 2023. Even a child looking at this graph will say, isn't this interesting? The more we're punching the planet, the more we're hurting her, the more she seems to be helping us. She seems to be acting as a forgiving mother to our childish abuse. The answer is, scientifically, that conclusion is correct. The more we've stressed the system, a healthy planet, a resilient planet, is able to buffer. When you count every year here, the number is remarkably similar. It's 50% every year of the carbon dioxide emitted from our fossil fuel burning is actually not remaining in the atmosphere. It's absorbed in the ocean, 25%, and another 25% on land. The latest number from the Intergovernmental Panel on Climate Change is 56% over the last few years. But this is a healthy planet. Unfortunately, we're starting to see cracks in this system. We're starting to see the first signs the planet is losing its health, its stability to buffer. Did you know, for example, that the richest ecosystem on land on planet Earth, the Amazon rainforest, that the Brazilian part of the Amazon rainforest has already tipped over and is no longer a carbon sink, it is today a carbon source. This is a warning sign that we have living systems on Earth that have this biogeophysical capacity to buffer and dampen, to hold the planet in the Holocene state, is now showing signs of pressure. And then comes fresh water. Well, the marine systems on planet Earth, if we go into the ocean, is the big drama here. We know that 90% of the heat caused by our fossil fuel burning is not in the atmosphere causing the climate crisis we have today. It's in the ocean. The planet is this massive thermostat. 90% of our climate forcing, the energy imbalance we're causing, is trapped in the ocean, hidden in the deep water layers. Now, every year since we started burning fossil fuels, the ocean has been warming, just like the atmosphere is warming. This is well predicted in models. We understand it. It's a deep concern. It actually affects and reduces the stability in marine ecosystems, but it also gives a feedback in terms of reinforced storms and more evaporation and harder and more intensive rainfall events, but it is a buffering of a planet trying to stay in the Holocene. 2023, we suddenly see the temperatures on the ocean go completely off the charts. It continues in 2024. We do actually not understand what's happening. What we are scientifically really concerned. Is this another example? First, we have what you see here on the screen, ecosystems on land starting to show signs of weakening. Are we seeing the same thing in the ocean? This is what we are really nervous about, because these are the systems that you see now on this rotating planet, the 16 so-called tipping point systems that we today understand regulates the stability of the climate system. And what you see here, they are everywhere on planet Earth. They are in the ice sheets, they are the big ecosystems, you have them in the permafrost, but you also have them connected through the freshwater hydrological cycle in the atmosphere, but also in the ocean. And that these systems are so interconnected that we today need to understand that if one or two of these tip, they can, through dominoes, cause cascades across all of these systems. Of these 16 systems, we today estimate that 5 of them are likely to cross their tipping points already at 1.5 degrees Celsius. And we're moving very rapidly to 1.5. Which ones are these 5? Well, 2 of them is the Greenland ice sheet and the West Antarctic ice sheet. These 2 represent 10-meter sea level rise. It would become irreversible if we would cross that tipping point. It wouldn't occur overnight. It wouldn't be a tsunami suddenly hitting the world, but it would be irreversible. So, of course, we have to stay away. And these are, therefore, boundaries. So the story I've told you so far of the Anthropocene and the tipping points and the Holocene gives us a risk assessment, for sure, a dire conclusion of the risks we're taking, but it's also a tremendous help because it allows us to quantify the safe boundaries to avoid crossing these tipping points, to keep the buffering capacity intact, to have a healthy system. So we can take the planet to the doctor today, not only because we can observe what's happening with the planet, but also because we can measure the safe boundaries. So that's why I'm so incredibly enthusiastic that we today can say, not only that we need to become stewards of the whole planet, also that we can become stewards of the whole planet, because we have the planetary boundaries, and that's what you see on the screen here. We've identified, over decades of science, the 9 large environmental systems that we today scientifically can say regulates the stability, the resilience, and the life support on planet Earth. And it's not only climate. What you see here, you have the biosphere boundaries, biodiversity, land system change, the 2 cycles next to the carbon cycle, the nitrogen and phosphorus cycle of nutrients, but also the bloodstream of the whole Earth system, the hydrological cycle, the fresh water which is behind all life, driving the photosynthesis, keeping carbon stocks intact, having healthy soils, producing all the food we depend on, and keeping the living biosphere in a resilient state. But it's also air pollution, it's also a stable ocean, it's the protective stratospheric ozone layer, it's novel entities and chemicals. All of these 9 are the ones that we now need to become stewards of to have a healthy planet. What you see here is the green safe operating space, is the quantified state to keep the planet as close as possible to the Holocene state that we all depend on. Unfortunately, what you see in these wedges is that 6 of the 9 boundaries are outside of their safe space. So this is the proof point that we are really at risk of weakening the planet. So, in short, don't get cheated to believe that it's only climate that is the only sustainability challenge we have. Oh no, even if you focus only on solving the climate crisis, it won't be enough to phase out fossil fuels. You have to come back into the safe space on the planetary boundaries to keep the carbon stocks and sinks intact, to keep the hydrological cycle functioning, to keep the health in the system in place, to avoid that nature itself tips us outside of 1.5 degrees Celsius. So that is what the story tells us, that now is the time to recognize the need to be stewards of the planet. Now, I won't leave you with just that diagnostic, even though I just have 2 minutes left, just to say that, can we transform back in? Is there a safe landing zone for humanity? The answer is yes. We know that for every one of these 9 boundaries, we have the solutions. We have scalable solutions that can take us not only towards solving these problems, but also taking us to a more prosperous and equitable future for humanity. And on freshwater, there is a new story. This is a very messy graph. It's for your eyes only because it will be delivered in a new report that we'll be releasing in a few months' time called the Global Commission on the Economics of Water. What I show here is the latest assessment of the atmospheric rivers of how evaporation from healthy ecosystems provides rainfall for neighboring countries, often across continents. And what this shows is that the freshwater cycle is not only the fundamental glue for life, it's also what connects us all as human beings on planet Earth. This is why we will be trying to make the world understand that the freshwater cycle is actually a global commons. It's something that we all depend on and have to manage in a collective way. And this is what I hope I can leave you with as a concluding remark, that a pathway to success today, a pathway towards a future where we leave behind for our children and for you in the future generation, a livable planet for many generations to come, is if we are able to understand as now is the time for us to become stewards of the entire planet, irrespective of where we live, irrespective of what scale we operate in, irrespective of what sector we're in. We must now connect entirely to the planet as a whole. And with that, I leave you with this for the dialogue to come. Thank you very much.
Brilliant.
Woo.
Johan,
Thank you, Johan.